بسم الله الرحمن الرحيم. محاضرة مادة المقاومة، الطالب حسين علاء حامد، المرحلة الثانية مسائي، الشعبة طاء. The lesson is about simple stresses and strains. Simple stresses are expressed as the ratio of the applied force divided by the resisting area, or sigma equal the force over the area. It is expressed of the force per unit area to structural members. They are subject to external force and or induced force. Stress is the leading of accurately describe and predict the elastic deformation of the body. Simple stress can be classified as normal stress, shear stress, and bearing stress. Normal stress developed when the force is applied perpendicularly to the cross-section area of the material. If the force is going to pull the material, the stress is said to be tensile stress and compressive stress. Developed when the material is being compressed by two opposite forces. Shearing stress is developed if the applied force is parallel to the resisting area. Example is the ball that holds the tension rod in anchor. Another condition of shearing is when we twist a bar along a longitudinal axis. Suspension bridges are a good example of structural that carry these stresses. The weight of the vehicle is carried by the bridge deck, and the press force to the strain is a vertical cable, which is turned supported by the main suspension cable. The suspension cable then transferred the force into bridge towers. The first kind of simple stress. There are three kinds of simple stress, namely normal stress, shearing stress, and bearing stress. Normal stress is the resisting area is perpendicular to the applied force. Thus there are two types of normal stress: tensile stress and compressive stress. Tensile stress is applied to the part end. The part to elongated while compressive strength and tend to short the bar. Sigma is equal the power over the area. When P is applied normal load in Newton and A in area in millimeter square, thus maximum stress and tension or compression occur over section normal to the load. An example for some normal stress: we take a hollow steel tube with inside diameter of 100 mm, must be carried tensile load of 400 kN. Determine the outside diameter of the tube if the stress is limited to 120. First, P equals sigma by the area, where P is 400 kN is equal 400,000 Newton. Sigma is equal 120. So the area is 1/4 by the d square minus 1/4 by 100 square. So that it's equal 1/4 by d square minus 10,000. Thus 400,000 equal 120 by 1/4 by d square minus 10,000. D square is equal 400,000 plus 300,000 by over 30 by. So D is equal 190.35 millimeter. The second kind is called shearing stress. Force parallel to the area resisting of the force causes the shearing stress. Is different to tensile and compressive stress, which are caused by force perpendicular to the area on which they act. Shearing stress is also known as tangle stress. Tau is equal V over A, where V is the resultant shearing force, which passes through the centroid of the area being sheared. For example of shearing stress, we find the smallest diameter bolt that can be used to fix a 3 plate as shown in the figure. If P is equal 400 kilonewton, the shearing strength of the bolt is equal 300 MPa. So the solution is tau is equal V over 2A. V is equal to tau A. If the V is equal 400 by 10 raised to 3 power is equal to multiply by 300 by 10 over 6 multiply by over 4 d square. D is equal 0.2914 meter. So D is equal 29.14 millimeter. The third type is called bearing stresses. Bearing stress is contact pressure between the structure body. Is different from the compressive stress as it is as initial stress caused by compressive force. Sigma B is equal power B over AB. Example about it in the figure below, assuming that 20 millimeter diameter rift join the plate that are each is 110 millimeter wide. The allowable stress are 120 MPa for bearing in the plate material and 60 MPa for the shearing of the rift. Determine A, the minimum thickness of each plate, and B, the largest average tensile stress in the plate. From shearing of the rift, P is equal tau by A rift. Thus equal is 60 multiplied by 1 over 4 pi multiplied by 20 raised to power of 2. So P is equal 6000 pi Newton. From bearing of the plate material, P is equal sigma B multiplied by AB. P is given as 6000 pi is equal to 120 multiplied by 20t. So T is equal 7.85 millimeter. The largest average of tensile stress in the plate, P is equal sigma multiplied by A. P is equal 6000 pi equal sigma multiplied by 7.85 multiplied by 110 minus 20. Sigma is equal 26.67 MPa. شكرا لكم.